Okay, Mr. Cook here again to supplement today's reading with another one of our fabulous films here. So today you're going to do a reading on light as ray and the law of reflection. Essentially we're going to build on the concept that light is a ray. It travels in straight lines, like if I have a little laser beam, even if it leaves the red dots, it travels in a nice straight line, and when it hits something it tends to reflect. The best reflecting surface that we know of is a mirror. Now, when I have a surface, particularly one that reflects as a mirror, it will usually show me something that's looking in it. We call what we see in the mirror or the reflective surface, we call it a virtual image. So I would be the real Mr. Cook. If I look in the mirror, there's another sexy version of me. That would be the virtual Mr. Cook. Also pretty thing, pretty good looking. The difference is it's a little swapped. If I raise my right hand, virtual Mr. Cook raises his left hand. Now when a beam of light is moving along, we call the beam of light as it hits something, we call that the incidental ray. Remember, when we're referring to light, we're referring to it as a ray of light. So incident means something beginning. You hear about we have an incident happening here. So incident is the light going to the surface. Once it hits the surface, it's going to bounce off the surface. And we call that the reflected ray. Just like when you look at your image, you call it, oh, look at my reflection. If we're looking at a reflection of a ray, it's a reflected ray. Now, in physics and in science, we like to measure that. We've noticed something happens. When it hits a reflective surface, it doesn't just bounce off anywhere. It has a very specific place. It bounces off depending on where it's hit. So if the incident light hits it one way, we can predict how it's going to be reflected. To do this, we first establish what we call a normal. A normal is an imaginary line we draw that is perpendicular to the surface, meaning it's 90 degrees. 90 degrees like the surface corner of this page. So if I have a mirror, I would create a normal line that is perpendicular to the surface, means it's exactly 90 degrees. For your notebook, you should have a little reference sheet like this, and it's going to show the angles we're talking about. And you notice directly going in, we have a normal line. The normal to the reflective surface, this little dotted line, is 90 degrees. For those of you who don't remember algebra, drawing a little square means it's 90 degrees. So we've established a normal is 90 degrees from the thing. It's an imaginary line. But as we measure reflection and refraction, great, I can't even speak today. As we measure the incident line and the reflected line, we're going to measure them to the imaginary normal line, as we see on the sheet. So when it goes in, and I'm going to show you on the worksheet, you should have these in your baskets. Bear with Mr. Cook here a minute. Let's see, does that look lined up? So, if I have a mirror, I could place my mirror, my reflective surface, on the line. The line going in, once again, is going to be the incident ray. So the incident would be where I am shining my little beeper, my little laser. And I'm going to measure it to the normal line. When it reflects off, it is going to give me a reflected line. Now here's where things get interesting. If I measure from the incident, in other words, the light shining into the normal, I call that my angle of incident, my light going in to my normal, and I can measure that. I'm not measuring to the mirror surface. I'm measuring from where I hit to the normal. And we call that the angle of incident, the beginning angle. Its reflection will be the angle of reflection. And that will be from the light reflecting to the normal. Here's what's kind of cool. Is if I know one angle, I know the other, because the angle of incident equals the angle of reflection. You can see this pretty easy here where I have my normal drawn, and I can see it hits the mirror right there at the imaginary line, 90 degrees. If I take my laser pointer and I follow my angle of incident and I follow it along the virtual line, notice my reflection goes along the reflection line. It bounces off nice and easy. If I change, I have these little hash marks here. If I go in and I hit right at the normal part, my reflection will follow the reflected line. If I do it wide, it will go. If I go at a really extreme angle, it will reflect at a really extreme angle. So by tracing from reality, the real image, along my incident line, the virtual line as it goes, my reflection will be at an exact angle. So this is kind of cool. So by knowing this angle, if I know my angle of incident, usually shown with a white line, it's going to be the same thing as my angle of reflection. Since I know my normal to my surface is 90 degrees, if I take whatever my angle of incident is and subtract it from 90, I could get this angle here if I desired. If I know my angle of incident, I know my angle of reflection. This would also be 90 degrees, so I take my angle of reflection, minus it from 90 degrees, I could get this angle. So, for today's reading, make sure you understand these vocabulary words. Make sure you remember that we always measure to a normal, which is the imaginary line. And our angle of incident will always equal our angle of reflection as we go along in a mirror. So, back to the real Mr. Cook. I guaranteed I am not virtual. This sheet will go in your notebook for references. Use it to get through the quiz. It will help you. Really make sure you understand the vocabulary and how to solve for different angles. Always remembering angle of incident equals angle of reflection. Normal to the surface is 90 degrees. Read carefully so you are calculating the correct angle. Have a good day.